Last up for this worksheet is topic 5, which is solving a formula for a specific variable. So we're going to have formulas that have multiple variables, okay? And our job is to isolate one variable, okay? So that's what it means to solve a formula for a specific variable. So I do have a little note here. Let me get my pen. Note. All right, solving a formula for a variable means rewriting the formula in such a way that the variable is isolated on one side of the equation. So whatever variable is in question, you want to get it all by itself on the left, everything else on the right, okay? This does not mean finding a numerical value for the formula. We need to be really, really clear on that. What we're doing is we're just rearranging the formula so that one variable kind of is standing on the left by itself and everything else is on the right. Okay. So, with all that said, moving right along. So, here's the good thing. The same old steps that are used to solve just like regular equations, linear equations in one variable can be used here. The bad news is these annoy students a little bit because they don't simplify nicely. Like when we're solving just a regular old equation, a linear equation in one variable, and we're trying to find the value of x, things kind of simplify down, down, down to the point where you just get x equals a number. These don't simplify like that, okay? So they can be a little bit more frustrating for students, even though they're generally quicker and easier to do, okay? So just go into it with an open mind, all right? The main reason we do this, there's a lot of reasons, but the main reason we're doing it now, in my opinion, is in the next chapter, we're going to take linear equations in two variables and we'll have to solve those for y. It's kind of the same process. Okay, so example 6 says solve each formula for the indicated variable. Okay, first we have P equals 2L plus 2W. Most of you probably recognize this as the formula for the perimeter of a rectangle. It is the perimeter of a rectangle is twice the length plus twice the width. We always know it as P equals, perimeter equals. But what if we wanted to know what length equals in terms of perimeter and width? Well, we could do that. Okay. So our job here is to isolate the L. So the first thing we want to do is isolate the term that contains the variable that you're trying to get by itself. Okay, so we want to start by isolating the 2L. All right, so if we're going to isolate the 2L, the issue right now is the 2W. Okay, so I've got this P equals 2L plus 2W, okay? I want to get the 2L alone first. So I need to get rid of the 2W. I need to move it to the other side, and I would move it with subtraction. And this is what I mean by things don't simplify. In regular old equations, we would be able to simplify things on the left and the right. The left ain't going to simplify, okay? P minus 2W is just P minus 2W. Nothing simplifies. So P minus 2W equals 2L. The two W's on the right, they do cancel, they just become 0. Okay? So pretty good so far. We have the L in a single term. We just need to isolate the actual L. Okay? So that means we need to undo the multiplication of 2 and L. So I would divide both sides by 2, and I'll show you kind of two ways you can handle this. For now, we're just going to divide both sides by 2. On the right, 2 divided by 2 is 1. 1 times L is L. And then on the left, we're just going to leave it as P minus 2W over 2. So that would be a perfectly acceptable answer. You would typically write the L first, so we would want the L on the left, and then it equals P minus 2W over 2. Now, there is another way that you could do this where it simplifies a little bit more. So we're going to kind of revisit this step right here. So we had P minus 2W equals 2L. Instead of dividing both sides by L, you can divide all of the terms by L. So you just kind of split up that division on the left. So we divide everything, don't divide by L, divide by 2. Did I say divide by L? I mean divide by 2. So we're going to divide all of the terms by 2 instead of dividing just both sides by 2. And when we do that, 2 divided by 2 on the L just becomes 1, so I get 1 times L. 2 divided by 2 on the W also becomes 1, so I just get 1W. And then P over 2 is just P over 2. Whoops, let me line that up a little better. And then again, you typically want to take the variable that you're solving for and write it on the left with everything else on the right. So we could say L equals P over 2 minus W. These are the same. Me personally, I don't care which one you do. I like this one better with the star beside it. That's what Jillian prefers. So this is Jillian's favorite, but I'm pretty sure Pearson is okay over here. All right. So if you like the one on the left, knock yourself out. If Pearson says you have the right answer in the wrong format, try it Jillian's way. Okay. They are the same thing. They're equivalent statements. The one on the right is slightly more simplified than the one on the left, but they are still both beautiful. So the one on the left, a little easier. If Pearson's okay with it, knock yourself out. Okay. You can do that one. All right. Now, there is a time when I'm going to insist on this one. Okay. And that is when we get to chapter 7. Okay. There's something very important we do in chapter 7 when we're talking about linear equations in two variables. All right. And you have to take these linear equations in two variables and you solve them for y. When we do that, I want it to look like Jillian's method. Okay. The Pearson method is not going to be ideal then. Okay. So please just know that. All right. Part B, we have x over 3 minus 4y equals 5. And we are told to solve for x. Now, the first thing I notice is I have a fraction, and fractions just tend to complicate things. So my gut instinct says, hey, let's get rid of the fraction. All right, so let's figure out our LCD. So the LCD in this case is just 3. So I'm going to multiply all of my terms by 3, and that's just going to get rid of the fraction. I think it's a little bit easier that way. All right, so I get 3 times x over 3 minus 3 times 4y equals 3 times 5. Okay? Now, for that first term, 3 times x over 3, that would just give me 3x divided by 3. The 3's would divide out, and we would just get x. Or you could say the 3 in the denominator divides into the LCD one time, leaving me with just 1 times x. And then negative 3 times 4, or minus 3 times 4, would be negative 12y. Equals 3 times 5, which is 15. All right. Now, our goal is to solve for x. We want to get the x all by itself. So we can go ahead and move the 12y. Okay. When we move the 12y, we're going to have to move it with addition. Okay. So we want to add 12y to both sides. Well, on the left, 12y minus 12y or negative 12y plus 12y, that just becomes 0. So I've got my x all by itself. I've got a single positive x, and it equals 12y plus 15. And that's it. All right. Now, I do want to just do kind of like an extra little problem here. In chapter 7, you could have something like 5x minus 4y equals, I don't know, 24. Okay. And typically what we do there is we solve for y. This is a linear equation in two variables. We'll talk all about it when the time comes, but this is a very classic example of solving a formula or solving an equation for a specific variable. So if I were to solve for y, I would first want to isolate the 4y or the negative 4y. So I would subtract 5x. 5x is on the left cancel, leaving me with negative 4y. That equals negative 5x plus 24. All right. And then I need to undo the multiplication of negative 4 and y. So this is where do it Jillian's way, this like super highlighted in pink. Don't divide both sides by negative 4, divide each term by negative 4. So we divide each term by negative 4. Give myself a teeny tiny bit more room. All right, so on the left, negative 4 divided by itself is just 1, so I'm left with y equals. And then negative 5 divided by negative 4, just leave it as a fraction. We would get positive 5/4 x. And then 24 divided by negative 4 would be minus 6. So you're going to see a lot of this when we get to chapter 7, okay? Especially, I think it's 7.2 maybe. Okay, so just prepare yourself. That is coming in the next chapter. All right, so that's it for section 6.3. Next up, we have 6.4, which is linear inequalities in one variable.